Oh.
I'm getting outfitted here.
I'll just introduce everyone once, so we won't have to do it. I'm Serge, product lead on Chrome WebRTC. This is my partner in crime, Justin, who's tech lead. Sam works with me very closely. He runs DevRel, so developer relations for Chrome Media, based in London. Pangu, hi Pangu. The guy with the long name. Pangu works with WebM, so the VP codecs and such. So he's going to bring a little bit of his knowledge to us here. And Dimitri has the fun job. Dimitri is going to start off by bringing a little bit of Google I/O here. And so we'll try to get a demo going. You might have heard about Cardboard. And Dimitri and Pangu built something pretty amazing on their own time or on the side for Google I/O using Cardboard and WebRTC. So I'll leave the honors to them.
Do you want me to explain or do you want to explain?
Yeah.
Okay, cool. So hi, my name is Pangu. I also go as the guy with the long name. And I work on the WebM project as well as video on Chrome. And Dimitri is one of the engineers who I work with, and Dimitri has done an amazing job. So I shouldn't take any credit whatsoever other than sort of helping him get here. So yeah, what we've sort of done is, how many of you heard of Cardboard yesterday or like through I/O? All right, how many of you find it interesting? A lower number. We were fascinated with virtual reality, and so when we heard that something like, so we had planned another demo for I/O. Essentially, we wanted to get a quadcopter and a submarine connected using WebRTC channels so that people at I/O could control these things in different parts of the world. And then we heard of Cardboard. And then we were like, OK, scrap everything. We have to work on this, because we found it so exciting. And the idea when we heard of Cardboard was that you are getting an Android SDK so that you can build apps which will automatically take care of virtual reality and all that stuff for you. And then we thought, why not the web? This should be as easy to code for the web for virtual reality as it is for Android. And we sort of started off with that mission, saying the web should be a great platform for virtual reality, and that's what we tried to do. So it's going to be a little bit hard to demo without the cardboard in your face, and unfortunately, I don't have a ooh, look under your seats moment today. So sorry about that. We tried, but I have to show you one thing. So we made a couple things. The first one is this little rover, who we call Dimitri. And Dimitri is a rover that can be controlled over the WebRTC data channels for both motion as well as this 3D camera sort of right in front of here. And what we did was we piped this through a little bit of a hack to make WebRTC work with it. But we essentially what we did was the video goes through an Arduino board as well as this XB transmitter, and transmits to a video capture card, which we've sort of hidden away right there so that you don't have to see how the sausage is made. And once the sausage is made, though, it's really tasty, because what you can do is set this up right here. And I'm going to do a live test to see if this works. All right, Dimitri. So what Dimitri is doing right now is actually looking through the cardboard, and his eyes are sort of placed onto this particular camera. And it moves as with the cardboard. It can also be controlled, but yes. So as we were testing this, we worked with Justin's team up in Seattle, and Zeke, another developer there, he was able to control this while watching up in Seattle, and all thanks because of WebRTC. So we are going to put it right here. Go ahead. So as it goes, Dimitri can see what's going on. And no, these are not killer robots. This is a very fun little Dimitri robot. So what we'll have is we'll have this set up here so that during the break, a few of you can come and check it out if you're interested. And yeah, I'll let the show go on, and I'll come back later.
Thank you. There's one great thing with Dimitri is that he feels no motion sickness whatsoever. I tried this for a few minutes, and after a while, you get pretty dizzy. So thank you. This is just an example of, with a little bit of time, a little bit of knowledge, and a bunch of open source code, what you can achieve. And you can build things that are completely surprising. I had not seen this before going to Google I/O, and I was completely surprised. So thanks, guys. All right, now Justin.
So I just want to sort of check. I just want to sort of add to what Serge just said right there, that if you'd asked me 3 years ago, when we first came up with the idea for WebRTC, would we use it to basically pretend like we're in virtual reality while we're driving a race car, I would have been quite surprised. But like, we've built this really strong platform that's really malleable. And it was very, very easy for Dimitri and his team, and in a whole different office, to get this all up and running. We even had it running over WebRTC so that you could connect to WebRTC, have the thing, and someone in our office in Seattle could actually drive the car. So like, we could take the technology and very quickly go after new opportunities. And I think that's one of the things I'm most excited about WebRTC. So anyway, on the platform, we've been hard at work on a ton of things. I made this little sort of tag cloud here, just sort of talking about the stuff we've done in the past 18 months. You can go through all these things, but your eyes may start hurting after a while because there's a ton of stuff on there. But I do like coming to these events and sharing our roadmaps, because some of the things that people tell us is that we've been waiting for feature X, and I'd say, well, we actually implemented that 3 months ago, or we've been waiting to do this, but we didn't know this was coming. And so I really like being able to go out and say, here's what we're working on, here's what we're trying to do, and if there's things that aren't on the roadmap, well, I'd like to sort of hear, like, what are we missing? Does this thing work? Apparently not. So that was the stuff we did over the past 18 months. Here's kind of where we are with Chrome 36, which is going to be going to stable, I think, in 2 weeks, and then Chrome 37, which is sort of later on in Q3. And so I'm not going to spend a ton of time going into every single thing here, because we have actually a lot of content for you today. But if you have questions about anything in here in detail, please come up and catch one of us later. But one of the big things we've heard from people is that trying to do like HD video, or even video on mobile, people say the video quality is not very good. And they say it's the codec, or they say it's WebRTC. And it turns out in many cases it's the network. And the way that video works over IP networks is that you kind of have to play this sort of black magic game of guessing how much capacity the network has. There's no API where you can say how much bandwidth do you support, because it's fully dynamic. It changes based on how many people are using the network, how much load is on the thing, and you can even depend on like what kind of network type it is. So you have to do this sort of thing where you do these probes, or you send a bunch of data, and you sort of see, like, did that work? Now I can send a little more data. What ends up happening is that if you end up making bad guesses about what the network can support, you either underuse the network, meaning it takes forever and the video bit rate is very low. Typically for HD stream, you want like 1 to 2 megabits of video. And if you're predicting less than that, you have a very chunky, blocky, grainy video. Looks terrible. If you overuse the network, things are even worse, because the video just turns black and freezes. So like this whole, yeah, exactly. Yes, you get robot voice. So getting bandwidth estimation right is a very hard problem. There's probably some people in the audience have worked on this problem and know what's involved. So we've been very hard at work on this. We want to make sure that we can make these scenarios like cardboard work great. And these require things that are more than just HD resolution. We're going past 720p, past 1080p, 4K type resolution. And if you're going to be sending 5, 10 megabits of video over the network, you better be able to ramp up to that sort of level very quickly. So in Chrome 36, we have an all-new bandwidth estimation algorithm that is much better about analyzing the sort of peculiarities of Wi-Fi, and ramps up faster, avoids mispredicting in many cases. If you're doing HD streams on Chrome 36, you should see much better HD quality. You should see it faster. You should see it more stable. We've also been trying to make sure that screencasting, the ability to share your screen and have that image be distributed to the world, works great. And there are a couple issues we had in previous versions where when we had a big scene transition, we would generate a very big video frame that could be like 50, 70K of data. And when we try to put that data on the network all at once, we would basically crush the network. You can lose packets. You would end up with a long delay, and like it would take a long time from the time you put a new slide on the screen to the time people could actually see that. We spent a lot of time tuning this, fixing it. It now works a lot better in 36, even better in 37. So now you should see that screen sharing performance has improved substantially. I talked to the Screen Hero guys just today, and we really want screen sharing applications to be first-class citizens in the WebRTC ecosystem. And if you're not seeing the performance where it's working great for you, we want to hear from you. Just a few other things we had. We now automatically will back down if we're on a low-power machine and we're kind of overdriving the CPU. We're trying to send like HD quality or something. We can now back that down and send a lower resolution automatically if we detect that we're overdriving the CPU. This we call CPU adaptation. New NetEQ is more, it's our adaptive jitter buffer. It's more efficient for stereo. And a bunch of things on the data channels to be fully spec and protocol compliant. On the 37 side, so 37 just went to, is cut and is going to dev channel, or it will be beta very soon. One thing we've heard consistently from developers is that the bar that comes down at the top of the screen asking for Chrome to use your camera is too hard to see. And then we know this because every single app puts in their own, hey, look at this thing up here in the user interface. That tells us we're not doing a good job. So we've been working on this for a while, and whenever you do something like this in Chrome, it's like you can't just replace the thing for WebRTC. It's like we have to go rework the entire permissions request experience across geolocation, WebRTC, everything. Well,
sorry. And you have to do it across Windows, Mac, Linux, Android, and you have to do it for, as Justin said, geolocation, offline content, all the permissions that a web browser needs to ask. So it turns out that this is a huge undertaking, and having all that privacy reviewed and approved and security reviewed and approved takes a long time. But finally, we're getting there, and you should start seeing this in Chrome 37 soon.
Finally. Yes. So your users should all benefit from this. And hopefully your poor HTML developers will not have to spend time aligning pixels for, like, point to the allow button. Some other things are retransmission of packets. We now follow RFC properly, and we also have now adaptive Opus FEC. So if you turn on the use in-band FEC parameter in SDP, it's not on by default right now. We hope to fix that in 38. We will look at the packet loss that's occurring on the connection, and we'll turn up FEC based on what actually we encounter. So if your network connection is great, then no FEC will be used. If your network connection starts to suffer, we'll start basically encoding redundant copies of the audio packets when using Opus to make sure that even if you have some dropouts, that the conversation is still intelligible.
And that's what FEC stands for, forward error correction for the web developers here. It means you sort of send out copies of the audio in case one of the copy gets lost, you have another one that came in.
Yeah, I'm going to use a ton of acronyms here. Opus has support for automatically, but the codec does not do it automatically. It needs a source of it needs a source basically indicating that here's what the actual packet loss is. And since we also have our own packet loss concealment inside NetEQ, we had to do a bunch of integration between that PLC and the Opus FEC processing. So you are correct that Opus does support this natively, but making this work inside WebRTC and Chrome was a substantial engineering project.
Right.
Otherwise, it would have worked already. So one other thing is on Mac, we now support we'll be supporting AV Foundation in Chrome 37. So previously, the devices, the thing you used to open camera devices was something called QT-Kit, which had its own sort of peculiarities, and that was the old and busted, and AV Foundation is the new hotness. So you should see better, more stable, like just in our crash rates, we can see this, performance in Chrome 37 on Mac. So looking forward, we continue to make significant investments in bandwidth estimation. We want to make sure we can ramp up faster. Currently, it takes, what was it, Serge, to get to HD? 15 seconds?
15, 20.
Yeah, I mean, and which is, we still feel that's too long. We're providing APIs to allow you to set the start bit rate. So if you know you're on like a LAN or dedicated network, you could like start out closer to HD. But in order to get up to 4K, we want to make sure we can start higher and ramp up faster, and make sure that in all these cases we're never overdriving the network. We also have some work being done to vastly improve echo cancellation to be much more tolerant of the cases where the operating system does not give us reliable delay values. The delay value is a very important part of echo cancellation, to know how much longer and further in time you should expect the reflected signal to come back in after it was played out from the speakers and back to the microphone. In some cases, it's very easy to tell because the OS tells us immediately how much time there is. In other cases, you kind of have to guess at it. We're working on improving things so that we can do a great job even when we need to guess. We're also adding new APIs to allow per-stream control of things like bitrate. That if you're sending multiple streams, you might want to say, this one we want to send in HD, and this one we want to send in like QVGA, because you want to send maybe a screen share plus your image. In the past, we didn't really have these kind of controls. We only had these very high-level constraints types of things. We couldn't say, hey, set the bitrate for this one particular stream. And we're adding a new set of APIs called RTC RTP sender and RTC RTP receiver, which basically gives you a new thing in the object model that gives you per-stream encoding control. This will be useful in WebRTC 1.0 for things like bitrate control, and additional things in WebRTC 1.1, which I'll talk about in a little bit. Another thing we've heard from is people want the ability to set what audio output device is being used. This is a very complicated security and usability sort of thing, but we know people want this. We're working very hard on it, and a bunch of stuff on the ICE side, being able to sort of limit yourself to only using relay candidates for privacy and other privacy-preserving techniques.
So I'll let you catch your breath and do the rest here. VP9, we've talked about it. Pangu will talk about it in a minute. Very important for us. We're going to start experimenting with VP9 in a way that you can also try it out. It's a better video codec. I won't talk too much about it right now. Noise reduction. Little tiny cameras are super noisy. They're not very precise. They have a very small sensor size. So the image they produce is often very noisy, and cleaning out that image in real time turns out is a quite complex mathematical problem that we are tackling, and hopefully you will see the benefits of this before the end of the year. Media stream recorder, the #1 voted Chromium feature request by far for our team. So we are absolutely going to tackle that, and you will also see the results of this before the end of the year. We've been using SCTP for our data channel API. We are going to start experimenting with Quick instead. Quick is an experimental... In addition, right, not instead. We won't be experimenting with SCTP. And this is going to be an interesting project, and hopefully we will be able to see much better network performance from data channels using this new network stack. And we are refactoring the way Chrome does audio. You're going to see us move critical components more or less outside of WebRTC and inside Chrome. So for example, if you're watching a YouTube video and you're in a WebRTC audio chat, the audio from the YouTube video won't go back into your chat through the speaker. So we'll be able to do sort of system-wide echo cancellation. So, and we're going to start doing this a lot more so that Chrome can take advantage of the WebRTC components, and WebRTC developers can take advantage of these components Chrome-wide. So that's also planned for the end of the year. And before we go on, it's important to mention that we base this roadmap and we plan our work. We're a small team. We plan our work very carefully, and we plan it based on the feedback you give us. So sometimes I'll go to Twitter and I will look at the WebRTC hashtag, and I'll see people complain about X or Y, but that's like screaming out in space. If you want us to hear some of your pain, some of your questions, some of your concerns, this is a much better place to go and share them with us than the WebRTC hashtag or just the usual complaining, because we really do listen and we really sit down with these things super frequently and plan our work through these tools. So the Chromium tracker, the WebRTC tracker, and the Discuss WebRTC list are your friends.
Couldn't
Thank
have said
you.
it better myself. I mean, we can look at these bugs by how many stars they have and say, like, what are the things that are really causing pain to developers? And just over the course of like the past quarter, when I generated this list, we ticked off, I think, about 70–80% of these bugs. So again, if there's something that's causing you an issue, please file it. You can send us email, bring it to our attention. But otherwise, it's just very hard to know like what is really holding people back. I also just want to talk briefly about mobile support. I talked about Chrome, and we're doing a fantastic job on Chrome for Android. You may have seen some of the things that are new in L, where web pages become really peers of native apps. Basically every web page is sort of in the recents view of of your task switcher in Android. Now every web page is a peer with a native app, so you can have a page that basically acts just like an application. That's a great sort of fit for a WebRTC app on Chrome for Android. But it talks about a few other things. Also in the L release of Android, both Web Audio and WebRTC are fully supported. So if you're building a native app but want to be able to use these technologies from web, you can now do that using WebView. And that's going to be part of Chrome v36, Chrome WebView v36. Another thing this is not really Android specific, but it really comes up a lot on Android, is tuning our bandwidth estimation to deal with cellular networks. We found that with Wi-Fi has a lot of interesting sort of packet patterns. Turns out not only is it not a truck, it's also not a series of tubes either. We're doing a lot of things just in looking at what the networks are actually doing with the data to make sure that video really works well. You all may have also heard 64-bitness. There's iPhone 5 supporting 64-bit. Android is also going to support 64-bit, and we want to make sure WebRTC works great. It's fully optimized for 64-bit scenarios. We've talked about video hardware acceleration a bit in the past. The Android K release was the first release to have VP8 exposed in the media codec API that's usable for real time. We're continuing to iterate on that, make sure it can be used for doing multiple encodes at the same time, multiple decodes at the same time, really respect proper bitrate changing, that sort of thing, and work across a variety of vendors. K was mostly Qualcomm and Snapdragon 800. We're making sure this works really well across a variety of other chip makers, including Samsung, NVIDIA, et cetera, to basically make sure you can get HD quality without being CPU limited, because you can offload all the stuff to the DSP block.
An interesting fact is that, for example, the Chrome OS Chromebook 2 by Samsung fully supports encode and decode of VP8 in hardware for any WebRTC app out of the box.
You may have heard the Android One announcement at Google I/O. Basically, there's a reference platform for kind of low-cost Android devices. We're going to make sure the WebRTC stack works really well on Android One as well. And while we do have Chrome for Android as a platform for WebRTC, we also support, as a first-class citizen, basically the Java native API is pureconnection.java. And we'll continue to make sure that pureconnection.java keeps in sync with the new APIs that are being added, as I mentioned on the previous page, for RTP sender and receiver and that sort of thing. On the iOS side, we're doing a number of just catch-up things, making sure we have the full set of APIs available on iOS. Data channels is like probably the biggest thing that's missing right now. And just talking to the developer working on this, they're trying to get this working as soon as possible. I think in the next couple of weeks, we should have full support, including SCTV data channels on iOS. And another interesting thing is just iOS has a bunch of great APIs for accessing the GPU, looking into what kind of hardware offload we can do for VP8 processing on iOS, as well as for camera capture. So Alex mentioned the state of AppRTC. And we've also been aware of some of the problems he mentioned as far as message delivery. You would think that kind of getting like a message from like point A to point B would be a solved problem in 2014. It turns out that this is actually very complicated. As Alex sort of went into detail on, we are going to be overhauling the back end of AppRTC to use some of the new technologies available in App Engine to make it way faster, way better about sort of preserving things like ordering, and just way more reliable. So if you're using WebRTC as a kind of a base for like your application, we should have a lot of things that will make joining a call much faster, and reliability, just like we want that to 100% of the time. You shouldn't have anything where the message got delivered in the wrong order and you had to fix it up on the client. That's now, you shouldn't have to worry about that.
Depending on when we get booted off stage by Tsahi, we might have a demo of an upcoming version.
Right. Yeah, and we also are working to make WebRTC. Sam here, our tireless DevRel advocate for WebRTC, is working on making it fully mobile-fied. So it works great on Nexus 7, works great on Nexus 5, works great on basically any browser that supports WebRTC. So that's long overdue, and very much looking forward to that being done. We also talked about turn a little bit before, and about how we do the load balancing for turn. If you go to my GitHub Juberti, there's a project called Compute Engine on Demand. And that's the thing I talked about before, where we spool up GCE instances that are running RFC 5776 turn server. You can clone that, hack on it. That's the secret sauce he mentioned. It's not secret anymore. Did
you just release it now?
Well, it was an Ami's GitHub before.
Okay.
Yeah, it was undiscovered. It was not really secret. It was the obscure sauce,
okay.
If you will. But the part that's even better about this is that the fact that you even have to do this at all on GCE is kind of crap. GCE should do this for you. That basically, if you have turn load that's increasing, you should be able to seamlessly and elastically scale up your turn clusters. And there's a thing called GCE replica pools. And replica pools already are really good about scaling up based on CPU. So if you're using GCE replica pools for your turn server, you're already kind of half the way there. And we're kind of pushing on the GCE team to add replica pool support where they can scale up based on bandwidth, which is kind of what you really, really want for turn. So long story short, we have Compute Engine on Demand for doing this now, but I'm hoping that the GCE infrastructure will also sort of do all the heavy lifting for us later this year.
And lastly, you're going to see us pay down technical debt, which means cleaning up APIs, removing old code, moving to newer APIs, a ton of refactoring. So things are going to change a lot in the code base for the better. This helps us make Chrome more responsive, helps us make our developers, our engineers much more productive. And so as you tag along with us on this journey, you're going to see some churn there. And if you're wondering what's going on, a lot of it is about paying down technical debt to make sure we don't become a huge bloated platform.
An example of this is just what Serge mentioned about the rewrite of how audio processing is being done inside of Chrome. And when we get to the sort of the promised land, not only will we have full browser echo cancellation, but we'll also have the ability to apply effects, web audio effects, on received media coming in a peer connection.
All right.
The spec. Okay.
I did that.
Yeah. it's very clever. Yes. Sometimes I do feel this way. So I would just talk on some of the big issues, a lot of questions, and some information I think that might be alarming some people incorrectly. I want to sort of set the record straight on some things. Get user media. We're trying to get this to working group last call. So we're very close, but there still are some things where there's still some argument going on exactly how you specify, I want this resolution, but not this resolution. I'm hoping this will get worked out, and we can get the spec to last call later this year and consider this done. WebRTC 1.0. So WebRTC 1.0 is basically taking the peer connection spec and getting that to last call, where we feel like we have the features we need for 1.0. It doesn't mean that WebRTC never moves forward past 1.0, but there's a consistent, complete set of APIs that can be supported across browsers, and developers know what they can expect. They can get deterministic behavior. And I'm hoping that we can get at least a working group in last call of WebRTC 1.0 spec later this year. And so that leads into, well, what happens past 1.0? And what is this thing I've heard about called ORTC? Is ORTC going to replace WebRTC? Do I need to rewrite all my code? Is this going to be a sort of schism between the two churches of WebRTC? I want to sort of head that off and say, ORTC will be integrated into WebRTC 1.1. There's already a bunch of concepts that I talked about earlier. RTB sender, RTB receiver. These are concepts that originated within ORTC and have been very definitely woven into the WebRTC 1.0 specification. So ORTC was kind of over here, and WebRTC 1.0 was here, or 0.9 was here, and we kind of moved WebRTC in this direction, and we're moving ORTC in this direction. So what you're going to get is your existing code is going to keep on working. You're going to get more knobs to tune things, and if you don't want to deal with the high-level things, you want to go right down to the low level and handle all the sort of settings and stuff like that, you can do that. So it's like the best of both worlds. Your existing code works, you get more stuff, and if you're a rock star expert who wants to really have all control, you're going to get that too.
So a normal evolution, basically. It's been spun off, is like Justin said, there's been a little bit of FUD around this.
ORTC and WebRTC are an evolution of or 1.1 is an evolution of WebRTC 1.0. Not a French Revolution with guillotines and all that. Okay, so codecs. This is another thing that's causes no shortage of controversy, and I want to sort of articulate what the Chrome position is on some of these things, and then we're going to have a fantastic update on VP9 specifically from Pango. So first, VP8. The short story is VP8 is Google's codec of choice. We think this is the right codec for the open web platform. We think this is the right codec for WebRTC. We are trying to get this in as many hardware places as possible across Android, across Chrome, making this hardware accelerated, getting the best performance for screen sharing, for HD, for 4K. VP8 is the codec, of now, and we are going to make sure that it's successful for people who are using it. So H.264, some folks have asked us. So I just mentioned the position that we have, but some folks have asked us, well, can I submit a patch to add H.264 into the WebRTC code base? And we're not ideologues here. So where there's a patch, we're working on integrating it. If you want to ship H.264 support where you bring your own H.264 from Joe's H.264 store, then you're certainly welcome to do that, and we will have the packetization support in WebRTC, the negotiation support, where that can work, but it won't be in Chrome. So if you want to build your own, application using the WebRTC source code, H.264 can be supported. You can integrate it very easily. But as I mentioned, we think the VP8 is the right choice for the web platform. But we think the even better choice, starting next year, will be VP9. And we hand it over to Pangu to kind of regale us on.
Was that a subtle dig that both of them were in black and white and this is in color?
Oh, it's 9. It's at least 1.25 times better. 1.125.
So before I get started on VP9, a couple erratas. First is, unfortunately, Dimitri has to leave, but instructions on how to build this will be coming up on g.co/ChromeVR. We already have a bunch of Chrome experiments there on that already works with Cardboard. So if you have a Cardboard, you should totally check that out. And if you don't have a Cardboard, you can actually build your own in g.co/Cardboard. The schematics are up there. So VP9. One of the things that we got started as we were thinking about codecs was, this is from a company called Sandvine, and they do this state of the internet sort of roughly twice every year. And this is from the second half of 2013. And it shows what are the different activities that sort of happen over the internet. And you'll see that 61% of peak internet bandwidth is taken over by video streaming. And this is across the VOD streaming as well as any form of video conferencing, etc. So we saw that number a couple years ago, and we were like, at that point, it was close to 50%. And that just scared us, because it clearly showed that global internet bandwidth was not growing at a pace that was keeping up with how much video is being consumed over the internet. And so I should have probably led with this question. Who here knows of VP9? All right. Whoa, that's a low number. So let me give you a quick introduction with respect to what we did to solve this problem. Our goal was, if we put a little bit more compute cycles, how much more can we actually compress the video? And I sort of really, really do injustice to the technology that goes in by sort of calling it compute cycles. But there's a lot of decisions that can be made at the time of encoding. And as And with Moore's law, as we get a little bit more compute cycles, we can actually compress the video further. And that's been the theory behind video codecs. And with VP9, we just sort of took it 1%, one step higher, where with a little bit more compute cycles, you can actually get now up to 50% compression for the same quality. Usually, I run a video to sort of show that I show a 264 clip and a VP9 clip, and we have roughly 50%. I'll actually send the links instead as along with the email, along with all these things. So over the past year, we announced VP9 in June 2013, and since then we've been working hard to ensure that YouTube runs on VP9. It was not an easy sell. It was a really, really hard sell, and I'll sort of tell you what were the benefits that we got because we were really trying hard to sell to YouTube. But the first one is that I wanted to give you an idea of what YouTube is in its current form today. So YouTube has over 1 billion monthly active users. It deals with over 6 billion hours of video on a monthly basis. 100 hours of video are uploaded into YouTube every minute, and that's increasing. And 80% of the traffic that comes to YouTube comes from outside of the USA. So and YouTube did a really, really hard job of making sure that 264 works for them. And we were sort of going to them and telling, hey, we've got this new happy, fancy new codec. Why don't you start using that instead? And they were like, nope, hold your horses. We want to see what the performance is, what the benefits are, etc. And so instead of sort of leading with how we did what we did, I wanted to sort of show you one more data point from YouTube, which was on the left, wait, that's the right. On the right, you have the uploaded videos in 2010 in YouTube and the uploaded videos in 2013 in YouTube. And that's roughly a 600% increase that they saw. And then you could also see, which is sort of like in the past, from 2008 onwards, what's been 720p and greater uploads in YouTube. And you can see, unfortunately, we can't give you the numbers, but this is one of those Bezos charts. It just goes up. So then we somehow imagine that we somehow convinced VP9. It was a lot of hypnotizing. And then they were like, OK, cool, VP9 works. Let's actually start re-encoding the entire YouTube catalog in VP9, and we'll start with the popular ones. And this includes 4K as well. And you'll see that the top chart is calling out what is known as the format distribution in YouTube. So YouTube needs to maintain a 240p video, a 360p video, a 480p video, a 720p video, a 1080p video, a 4K video, and all the other ones in between, in order to make sure that we give you a great streaming performance in YouTube. So format distribution is one of the biggest challenges for YouTube. Now imagine that now you need to seed this across all the caches across the world. What do you keep, and how do you keep it, etc. And with VP9, our goal was, if you can encode the video in VP9, we will just halve the bitrate overall. And as a result of that, you should be able to see you should be able to store more content and egress more content. And that's what you sort of see. Another one with no numbers sort of shows you how the format distribution changed. And think of this as 1080p, 720p, 480p, 360p, 240p, etc. That's the amount of storage that they contain and how we've sort of shrunken that down for YouTube. I won't bore you with this. So, OK, all right. Why YouTube sort of keeps these various formats is also so that we can adapt the video for you, so that you get a much better streaming experience. And with HTML5, we sort of added MSE to make sure that YouTube can take advantage of this adaptive streaming. And using that as well as Dash, what we've been able to do is sort of give you a really fast streaming experience. And you can sort of do this on your own. Go to YouTube today in your hopefully crappy Wi-Fi connection, and hopefully that's not true. But with less than 1 Mbps, earlier you could barely stream 480p content on YouTube without encountering the rebuffer circle. Today you can stream 720p if that video is encoded in VP9. And it will be a pretty smooth experience, if not file a bug. And how you can sort of check if that particular video is VP9 or not is you can right-click on the player, and you can see a thing called Stats for Nerds. And then you can see what's the MIME type for that particular video. It will say VP9. So in order to convince YouTube, let me just see if I have some more numbers here. All right. So YouTube adopted VP9, and today more than 60% of daily playbacks on Chrome are done using Dash VP9. And this has had a tremendous benefit for them. And some of the numbers that I want to sort of highlight, but I couldn't get it in, were the first one is overall worldwide, now you see 25% more HD video content as a result. And they load 15% faster. And this is because we've been able to reduce the bitrate because the codec provides that corresponding benefit. Along with that is also the fact that we've made VP9 really, really, really fast so that YouTube can actually use this. So we've added multiple points now between the computational efficiency and the compression efficiency that you wanted to do so that VP9 can be used by YouTube and the likes, as well as WebRTC. So you'll see that this is a VP9 speed parameter chart that we use, which is, think of speed 0 as sort of like the kitchen sink where we use all the encode tools and consume as much of your CPU resources as possible. With every step, we have tried to give you a slightly lower compression efficiency, but a much faster performance from VP9. So you have to sort of read it as, if you use speed 1 over speed 0 of VP9, you will get 7 times, it'll be 7 times more faster, and you will get roughly 95% of the compression efficiency that you would have had if you had used speed 0. And the jump at speed 5, which is now, it says that it's 57 times faster than speed 0 is, so that speed 5 is sort of our beginning target that we are trying to look for WebRTC. So roughly 5% speed efficiency drop for a speed increase until speed 4. And at the beginning of this year, when we started working on the real-time mode for VP9, we were 25 times slower than real-time, which means that for every frame that you need to encode, it's too high. It's too high. And today, we are at a point where we can now give you roughly, for 2.2 times real-time speed, we can give you significant compression efficiency. But we've added a little bit more speeds here, and I don't have that chart here. But so we have 2 speeds right now in VP9 that is functional that you can test for real time. The first is at speed 5, which is roughly 2.2x and gives you 40% compression efficiency, and speed 6, where you're roughly 40% more CPU cycles, but it gives you 20% compression efficiency over VP8. We've started testing this in certain cases. So for example, we hacked together a Chrome remote desktop experience with VP9. The visual quality is phenomenal, and for text especially, we have added I444 experimental support as well. You can see almost lossless text rendering, and for that extra 40% more, we see roughly 20% gains in compression efficiency. We are very confident that we will get it to you by the end of this year, as Serge sort of mentioned earlier. And just wanted to give you a quick note on the adoption. Today we are on Android, Chrome, Firefox, and Opera, and more than 1 billion devices can already play VP9 today. We are part of the Media Codec APIs from KitKat onwards, and we'll have some more stuff for L. I think that's it. Thanks.
%60 of all YouTube videos on Chrome are using VP9.
Yeah, so we're talking about millions upon millions upon millions of minutes every day with VP9, and compare that to HEVC. I think that we're in a very nice place for VP9. So
thank you, Pangu. Thank you very much.
So again, VP9, the future. And let's talk about current day adoption of WebRTC.
And we'll have to be quick because time is running out, and we have some fun stuff to talk about.
Do you want to take this?
Yeah. So we're tracking over 300 companies that are deploying WebRTC technology today. And in fact, I think Sahi is going to say that number is wrong. 450 now. So if you're doing anything with WebRTC, talk to this guy so you get tracked. We've got about 1.7 billion WebRTC-enabled devices. That's our estimate by the end of the year. If you include all the mobile phones, all the desktop, the penetration of the HTML5 capable browsers that support WebRTC. And wow, where did that number come from? 2018.
The projections.
Up and to the right. All right, so basically even dogs will be running. But just to say, like we have watches. We're going to have all these devices that are going to be around us. And these devices are going to be built on top of the same kind of technology that we have in our phones, that we have in our laptops. And so the WebRTC experience, right? It's going to be in remote control cars. You can imagine this being the gift of the year for Christmas this year or next year. And so as the hardware becomes commoditized and the open software finds its way on all that hardware, this is not a hard thing to believe. So I'm looking forward to 2018.
So this is current day.
Current day.
Based on our own stats. These are not projections. These are real stats.
We've got 300 million 30-day actives on Chrome for Android. We have Chrome and Firefox interoping and Opera. And this is not just a sort of you make a blog post, woohoo, we've achieved interop, and then you go forward in life. We actually do integrated tests. So on a daily basis, there are hundreds and hundreds of calls made by our test bots that bring up a virtual Firefox, they bring up a virtual Chrome, and they place calls between each other. We're trying very, very hard to maintain this interoperability, and we're working closely with the Firefox team, and this is also a testament to the standards community that are helping us out with this. I don't know if you want to talk about the under consideration for Internet Explorer.
So just coming back to the ORTC point, there's a status.modern.ie. Basically lists IE's current proposed future support for a bunch of web technologies. And Microsoft has said on that site that they are currently looking at supporting ORTC. My expectation, sort of based on just intuition, is that we should see WebRTC support coming in Internet Explorer very soon. I can't speak for our friends in Cupertino right now, but nobody wants to be the only person not invited to the party. So
we talked about this. I guess we can just skip it.
Well, 1 billion.
1
Their
billion,
Android 30-day actives.
Huge thing. Lots of work went into this. Any questions? All right.
So you want Sam cover this?
Yeah.
Just a quick word about the resources we have for web developers. Justin's already mentioned the reference video chat app, WebRTC. Like he said, as well as a stack of work on the back end stuff, we're working on improving the UI UX for that particularly, so it will work really well across multiple devices. And also kind of optimizing the JavaScript and so on. We've moved the kind of reference WebRTC samples that are built by the WebRTC team to GitHub. And we really, really welcome the patches and issues that we're receiving for that. So please, we'd love to see your samples and anything you're having problems with our samples. And again, we've tried to build all those, kind of refactor them so they work there's demos for all these samples via GitHub pages on that site, and they are refactored in order to work on mobile. We also have, for people who are learning about WebRTC, we maintain a code lab, which is currently on Bitbucket there. And I also maintain this giant list of kind of everything to do with WebRTC. So check that out, and please feel free to add to that. We have obviously Google Plus for WebRTC with that, and there's the Bitbucket Code Lab. And just one last thing, as you can see from the numbers on these I/O videos, there is incredible interest. We find from my perspective, there's incredible interest in WebRTC, relative to other APIs, I think. And so if you're doing WebRTC stuff, I think you're in the right business.
Yeah, the 2012 video is the number 5 most watched video of all Google I/O for WebRTC, and the one for 2013 was the number 3. Yeah. So
let's see what we get this year.
Yeah, well, it's
and this is an interesting thing, right? I mean, we did a little gather up like this in January, and we had about 35 people show up. And today, we didn't have Chris helping us, though. So it's amazing to see the interest. Now, I think I'm going to hack the agenda a little bit, because we went a little bit over time. What we're going to do is we're going to go past the question section, And we're going to come back to the questions after the break and after the demos, so that those of you that need to leave can leave, and those of you that are interested in listening to us answer these questions can do that. And so we don't cut into the time of the people that prepared demos for us today. Is that okay?
Can we do one more thing?
Yeah.
Okay. So we've seen great uptake from people actually shipping real applications this year. I mean, already in 2014, we've seen Snapchat roll out with WebRTC-based video chat, and the Amazon Mayday service, which is also powered by WebRTC. So it gives me great pleasure to announce that starting today, Google Hangouts is now rolling out on WebRTC. This is a long time coming, and a number of people asked, why you guys have been working on WebRTC, why isn't this here yet? We had a bunch of stuff to do. For one, we transitioned from a different codec to VP8. That was a pretty heavy forklift. And we also wanted to make sure that we didn't regress any feature functionality. So this version of Hangouts, based on WebRTC, is fully provides all the features that you come and expect in Hangouts. It includes things like screen sharing. It includes Hangouts video effects, which is accomplished using something we do in native client for video stream processing. And it supports the whole group video chat experience. Hangouts on air, all that. So
it's slowly rolling out. If you install Chrome Beta, Chrome Dev, you're going to most likely get it off your Gmail account. And if you're on the Chrome stable, we're slowly rolling it out. And that rollout's going to take a little bit amount of time as we do these things carefully. But give us feedback. Install Dev or Beta and give us feedback.